Hello class, we are back for class Math 140. This is your instructor, Cindy Enrique, and I'm going to be going over section 6.2, which is factoring trinomials of the form x squared plus bx plus c. So what's special about this form is that I have a trinomial, and the leading coefficient is going to be 1. So when we're factoring a trinomial, usually students like kind of a guide. So the AC method has this guide where we draw an X, A times C is up on top and B is on the bottom. And we're going to use this type of format, which is going to be a useful tool when we are factoring trinomials. So here we go. We want to go ahead and factor this trinomial. So when I look at this, I have to identify my A, my B, and my C value. So notice here, when it doesn't have a leading coefficient, it can default to be 1. So I have my A is equal to 1. Here's my B value, that's equal to 7. And my C value is the constant, so that's 12. So if I'm making the chart to help me, I know that up on top, I have A times C. I have my B value. And this is what I want to make. So I want to multiply to A times C. And I want to add to B. That's your goal there. So, okay, let's put this into play. So A times C is 1. And my C value here is 12. So that would be 12. My B value is 7. So I want two numbers to multiply to 12 and add to 7. So if you need to, you can kind of make a chart. I know that 1 times 12 is 12, 2 times 6 is 12, and 3 times 4 is 12. So what combination is going to multiply together to give you a positive 7? So 1 and 12 cannot give you 7. 6 and 2 cannot get you 7, but 3 and 4 can. So I'm going to change this to a positive 3 and a positive 4. That means when I rewrite this polynomial, I have this x squared plus 7x plus 12. That's what I started with. But what I'm doing is I'm rewriting this middle term. So rewrite middle term. I already know how I'm going to rewrite it. That's where I got the 3 and the 4 from. So I have my x squared plus, and now I'm going to write my 3x plus my 4x, because that's what I had gotten. And now I have 4 terms. So then from here, what I'm going to do is I'm going to factor by grouping. So the first two have an x in common, so I'm left with x plus 3. The last two terms have a 4 in common, so I have an x plus 3. And remember, if that's an addition sign, you want to drop down whatever that sign is. So now I can definitely see that my common factor, I have an x plus 3 and I have an x plus 3. So x plus 3 is going to be my common factor, and the leftovers go in its own set of parentheses, so x plus 4. So that is one way to factor using the AC method. So I use the AC method. And that is supposed to help me. Okay. So now for the second one, I'm going to try trial and error. So trial and error just means I'm going to guess it and I'm going to check it and see if I can come out with it. So 35, let's look at the multiples. So if I have 35, I have 1 times 35. And I have 5 times 7. So are any of those combinations going to add together to give me 11? So let's see, 1 plus 35, nope, that's not going to give it to me. And if I have 5 plus 7, the best I can hope for is 12. So there's no way that I can get a combination of 11 when I have to have my multiples of 35. So this is actually going to be prime. So that's me trying to do trial and error. That was trial and error. And if you're like, whoa, that didn't make any sense. Okay, well, let's try the AC method. to do the AC method, don't forget you have your A times your C and your B value. And what you want to make is a new B value. So I still have my y squared. Let's change the color there. I have my y squared plus 11y plus 35. So I'm going to have my A is equal to 1, B is equal to 11, and C is equal to 35. So up on top, if I have A times C, that's equal to 35. That's up here. And my B value is 11. So I want two numbers to multiply to 35 and add to 11. But again, I run into the same problem. 1 times 35 and 5 times 7. There is no way that I can get these to add to 11. It is just not possible. So therefore, again, it's going to be prime. Okay, so let's try that again in our next example. So over here, let's try the trial and error. So if I'm trying the trial and error, then I'm going to look at that last term, 12. Well, I know that's 1 times 12, 2 times 6, and 3 times 4. So I want a combination that's going to add to 8. So the only combination that's going to add to 8, well, it can't be 1 and 12, it can't be 3 and 4, then 2 and 6 will work. So since that's going to work, I know that if I have g squared plus 8g plus 12, that's going to factor as g plus 2 and g plus 6. Okay. Now if you're like, okay, I don't really understand that, and I really like the AC method. Well, that's fine. We can also do this using the AC method. If I'm using the AC method, and remember, I still have my g squared plus 8g plus 12. So I have my A is equal to 1, B is equal to 8, and C is equal to 12. And I still have my A times C up on top, my B on the bottom, and what I want to add up to. So my A times C, that is going to be 12. My B is going to be 8. So the numbers that are going to multiply to 12 and add to 8 is going to be 6 and 2. So I would rewrite this as g squared, and now this is how I'm rewriting it, plus 6g plus 2g, and then I have my plus 12. So remember, all I'm doing in the AC method is I'm rewriting that middle term so I can have 4 terms, so I can split it, so I can do factor by grouping. So the first two, what they have in common is a g, so I'm left with g plus 6. The last two terms, they have a 2 in common, so I'm left with a g plus 6. So I can clearly see that my common binomial factor is that g plus 6. And whatever is left over is my g plus 2. And notice how I get the exact same answer. So it really just depends on what you are comfortable with and what method you like better. So it's totally fine to do trial and error, and it's totally fine to do the AC method. It really just depends on you. Okay. So down below, you're not going to get any better at factoring if you just watch me do this. So you guys are going to practice factoring, and I'm going to pause this so that way you guys can pause and think about how to do these problems. So I'm going to pause, work on these problems, and then check for the solutions. Okay, press pause. Well, hopefully you guys took my advice and paused, and here are your answers. Hopefully you worked that out. So for that first one, I got C minus 9 and C minus 4. For the second one, if I have this 63, well, the multiples of 63 is 1 times 63, 3 times 21, and 9 times 7. There is no way that any of these combinations are going to add up to 21, which is that middle term. So this does not factor, therefore it is prime. Even if you did the AC method, it wouldn't have worked. For number 3, I see that they all have a 2 in common if you look at the coefficients. So the GCF is a 2, so I make sure that I pull that out. And then I have a trinomial, and I can factor that further. For number 4, I can see that they all have a 7q as a GCF. So I go ahead and factor that out. And here that q squared minus 7q minus 7, that can't be factored anymore. So that's as far as I can go. For number 5, again, I have a GCF of xy. Look at the trinomial. And we already looked at 63, so I know a negative 9 and a positive 7 add up to give me negative 2, and a negative 9 times a positive 7 is a negative 63. For number 6, my GCF was a PQ, so I go ahead and I factor out a P and a Q from all 3 of those terms. And then I have a trinomial. So if I'm looking at 70, I found 10 and 7, and I factored that completely. And then for number 7, I see here that I have a common binomial factor, which is x plus y. So I made sure that I factored out that x plus y from all 3 of those terms. So what's left over is that z squared, that 7z, and that minus 30. And that can be factored further. So that was z plus 10 and z minus 3. So that is section 6.2. Hope that helps.